Welcome back to the class. I'm Professor Amit Brambut at Laurel Ridge Community College, and we are going to go over CSC 208's Chapter 5, Loops and Iterations. Today we are learning how to write loops and control structures that automate repetition. We'll also explore indefinite loops that run until condition changes, definite loops that iterate through the set of items, loop idioms for tracking aggregates, counts, averages, and extreme values. Let's get started. Let's look at indefinite loops using the while statement. A while loop acts like a continuous conditional gate. It evaluates a condition if it's true. It runs the indented code block and then returns to evaluate the condition again. Look at the indefinite loop trap on the right of the slide. If you do not update your iteration variable inside the loop, conditional conditions remain true forever, and your program freezes in an infinite loop. Always ensure your loops have a clear path to exist. Sometimes you need to exit a loop immediately, regardless of the loop condition. For this, we use a break statement. When Python hits a break, it halts the loop execution instantly and jumps to the first unindented statement outside the loop. Look at the terminal example. By using the while true, we create a loop that runs indefinitely until the user types the exact string done. This is a highly useful pattern for processing interactive user inputs. While the break statement exits the loop entirely, the continue statement simply halts the current iteration and runs and jumps straight back to the top of the loop to start the next step. In our code example on the slide, it uses if the user input starts with hashtag, the continue statement runs, skipping the print command and returning directly back to the top of the next input prompt. This is ideal for skipping commands or filtering unneeded records. Definite loops. This brings us to the major transition, definite loops. While indefinite loops run until a condition changes, definite loops iterate through a predefined set of items, such as the list of names or lines in a file. Definite loops use Python for statement. They run exactly once for each item in the sequence. Because the sequence has fixed boundaries, definite loops are guaranteed to terminate safely, completely eliminating the risk of infinite loops. Now that we understand the syntax of both while and for loops, let's look into loop idioms. The common design patterns we use to extract the meaning from data. We will learn how to use loops to count items, calculate sums, compute averages, and find extreme values like images and smallest numbers in a dataset. Let's look at how we build smart loops. Here's a smart loop execution path. To build a smart loop, we follow a simple four-step process. First, we initialize our tracking variables before the loop starts, such as setting counter to 0. Second, the loop runs, extracting processing one item from our dataset at a time. Third, the loop updates our tracking variables and based on the current item. Finally, once the loop completes, we inspect our tracking variables to output our final analytical result. Finding the largest value. Let's look at the classic loop idiom, finding the largest value in a list. We initialize tracking variable largest so far to a low sentinel value like -1. As the loop processes each number, it asks, is this a number larger than the largest value we have seen so far? If yes, we update our tracker to new value. By the time loop completes, our tracking variable is guaranteed to hold the maximum value in our dataset. Core loop idioms compared. This comparative table shows our core loop idioms to count the items while you initialize counter to 0 and add 1 on every iteration. To some values, we initialize total to 0 and add current item's value on every step. To search for a specific value, we initialize the Boolean variable to false and set it to the true as soon as we find a match. Finally, to filter data, we use an if statement inside the loop to isolate and process the records we need. Sentinel variables, finding the smallest. Finding the smallest value is slightly trickier. If we initialize our tracker to -1, our loop will fail because positive numbers are never smaller than -1. To solve this, we use a sentinel value of none, which represents an empty variable. On the first iteration of the loop, our tracker is none. We automatically assign the first number in the list as our starting point. This ensures a safe, mathematically accurate baseline for the rest of the calculations. The identity check versus equal sign. When working with sentinel values like none, Python gives us a specialized operator is. The is operator checks for an actual memory identity. It asks if two variables point to the exact same physical objects in memory. This is stronger and more specific than equals operator, which only checks for value equality. Use is and is not exclusively when checking for Boolean states or sentinel constants like none to keep your logic highly secure. We have covered the indefinite loops and definite loops, loop control statements like break and continue, and the core idioms for analyzing data today. Do you have any questions? If so, please email me your question and try to be as descriptive as you can. Please look into your course material provided on Canvas and various links provided there, and let me know if you're stuck anywhere. Take care and see you in the next class.